Hey guys, welcome. Yeah, so this is example 2, and I might make one more example if I find a very interesting problem, or this might be my final example for this sine angle addition formula. Actually, if you look at this problem, we're going to have to use the sine angle subtraction or difference formula, right? Look at this minus sign right here, yeah? Okay, cool. But the task at hand is as written right here. So how do we get started? Well, like this. First, we see that the sine angle difference formula goes like this. The only difference is, like, for the sine angle addition formula, we had a plus here and therefore a plus there. And yeah, so easy enough to remember. If you remember the sine angle addition formula, just replace the plus signs with minus sign. Yeah? Okay. Cool. Otherwise, we see that, and what we have to show on the left side, this here is alpha and this here is beta. And so let's claim it as such. That is, let arcsine of root 3 over 2 be alpha, and yeah, beta be that. Okay, cool. And then that in turn means that sine alpha is equal to root 3 over 2. In other words, saying that alpha is equal to arcsine of root 3 over 2 is the same thing as saying that sine of alpha is root 3 over 2, right? Okay, cool. And the way you get here is by taking the sine of both sides of this. Remember, arcsine means sine inverse. And then similarly, this here can be translated to this here. They're equivalent. Saying this is the same thing as saying that there. Yeah? Okay, cool. And we prefer these guys as opposed to these first two guys, yeah? Because now, from here, what we're going to do is, well, if sine of alpha is root 3 over 2, then we can draw a right triangle such that sine of alpha is root 3 over 2. In other words, the opposite side is root 3 and the hypotenuse is 2. And so then, using Pythagorean theorem, we can complete the triangle and know that this side has got to be 1. All right. And then similarly, tan of beta being 1 over root 3 means the opposite side of our right triangle is 1 when the adjacent side is root 3. And again, using Pythagorean theorem, we see that the hypotenuse has to be 2. Where to from here? Well, we know then what we have to do to find sine of alpha minus beta. Remember, we said that this is alpha and this is beta right here. Yeah. So sine of alpha minus beta by the formula up here would have to be the right hand side here. Okay, cool. And so that's that. Because we know from the get-go what sine of alpha is, right? Sine of alpha here. Because, yeah, we translated this guy into this. So we know from the get-go that sine alpha is root 3 over 2. That's right there. But for cosine beta, which we weren't given, once we figure out all three sides of the triangle involving beta, we can see that cosine of beta is adjacent over hypotenuse. So that's root 3 over 2 right there. And, yeah, and you see the rest of it. And now all we have left to do is simplify. And root 3 times root 3 here is going to be 3. And then 2 times 2 is going to be 4. So this product here is 3 over 4. And this product here is clearly 1 over 4. 3 over 4 minus 1 over 4 is going to be 2 over 4, or 1/2, not 1/4. Jesus, how did I miss that? All right. So this should here, this here should be 1/2, not 1/4. Clearly typo. Yeah? Okay. So I guess I could do something about it. Let me, like, not leave a mistake. Let me just leave it unreduced as 2 over 4. And that way, like, yeah. Okay. There we go. Yeah? Okay, cool. I hope you enjoyed this. And like I said, if I find a really interesting problem, I'll make one more example. All right. Take care.